All right, let's go ahead and get started with our online lecture for Engineering 111. If you saw the email, we're not going to meet next Tuesday, so I've decided to just record the Casio operations that we were going to cover in class on Tuesday. Most of the stuff that we're going to be covering in this video is fairly procedural, so I think the video will work quite well. Let me go through a few real quick announcements. So first off, just a reminder, homework 2 for operations for the Casio is due on Thursday, February 2nd. That might seem like a little bit down the line, and it is, but this is one of those homeworks that if you attack it a piece at a time, it won't be so bad, but you'll definitely not want to wait until the last minute to finish this. One last reminder in regards to the Richard F. McCormick Technical Conference. If you'd like to volunteer, just contact Logan Stacks at stacksl@marshall.edu as soon as you can. You should, of course, be free because the beginning part of the conference happens during our lecture. Okay. Now, as you recall, class is also going to be canceled on Thursday, January 26th, because that's the date of the conference. If you don't want to attend the conference and you want to just go to class and work on homework, the computer lab will be open, so you're more than welcome to come if you'd like. And if you have any questions, I'm going to be out of town for the next few days, but if you have any questions, I can, of course, be reached by email. I'll have my phone and tablet with me at all times, basically, so if you've got any questions, just reach out to me and I'll try and get back to you as soon as you can. So today what we're going to do is go through a few more of the functions of the Casio. Again, we're not going to cover everything that the Casio can do during regular lecture, so there will probably be some snippet videos added to the playlist on some of the other functions that the calculator can perform. Okay, so let's go ahead and get into the lecture topics for today. So we're going to be talking specifically about three options as they relate to the Casio, particularly the CALC function, looking at the solve function, and then looking at some of the modes that the calculator can operate under. Before we get into the details, just a note: I will be opening and closing this Casio emulator throughout the lecture, just like we used last time. And I'll also have this key log above me. So, for instance, if I enter in some numbers, you can see the key log is replicating what I'm entering on the screen. So hopefully you should be able to follow everything. I will probably clear the key log from time to time just to ensure that everything that's going into it is fairly clear. Okay, so let me start my lecture actually by shift 9, 3 equals, and then hit SC. So now the calculator is cleared and we're sort of starting with a blank slate again. So let's get into it. One of the very powerful expressions or functions that the Casio has is what's called the CALC function. Now, if you look at the calculator, you'll see the CALC function right here. It's right under the Shift button, the CALC button right here. And it's a pretty nifty tool that the calculator has built into it for if you want to solve multiple expressions over and over again. So we've got a pretty simple one here in the slide. Let's say we've got the expression 3a plus b. And let's say that this expression is something that we want to evaluate over and over again for varying values of a and b. And this is a really simple expression, but there are a number of cases where in engineering where you've got the same equation and you need to get different values based on different inputs, and you need to solve the same equation over and over again. Well, if you can just sort of quote-unquote program the calculator with this particular equation, you could solve it over and over again quite easily. So the way that works is I'll bring the calculator up. The first thing we want to do is actually program the expression into the display, and it's pretty basic. Since it's 3a plus b, we just type in 3. We have to call a, and if you look at this sort of row of buttons right here where you have the sine, cosine, tangent, all this rows, you can see A, B, C, D, E, and F. Well, those are called by using the alpha command. So we would go alpha A, so that calls A, and since 3A plus B, we go plus alpha B. And if you notice, if you look here at the key log, that key log is actually matching what's on the slides. So if you want, you can pull the slides and you can literally button for button replicate a lot of these examples that are in the presentation. So I've got the expression built into the calculator. Well, what do I do with it? Well, once I've got the expression built, I can press the calc button, and then the calc button will evaluate that expression for various inputs. So let's say, for instance, pulling back up the calculator, let's say I want to evaluate this expression for an A value of 5 and a B value of 10. So we can do some mental math and we can say, well, if A is 5 and B is 10, 3 times 5 is 15, plus 10 is 25. So the answer should be 25. So if I hit calc, it's asking me for a value of A, so I'll say 5 and hit equals, and then a value for B. I'll enter 10 and hit equals, and it then tells me that 3A plus B is 25, which makes sense. The advantage is now I can do this calculation all over again if I want to use, say, an A of 7 and a B of 20. So if I hit equals again, now we're back into input mode. So an A of 7, enter, and then 20, enter. And it does the calculation again. So this is a fairly basic expression, but if you have a really complicated expression and you need to evaluate it over and over and over again, then using the calc function is really beneficial, and it's definitely something you'll want to explore. Let me clear my key log. Actually, no, wait. To exit the calc mode, all you have to do is hit the AC button right here, and now you're back into normal operating procedures for the calculator. So let me right-click, clear all, just clear up my key log, and then we're back to basic operating procedures. So that's basically the long and short of how the calc function works. And again, for a simple expression like 3A plus B, there probably isn't that much benefit, but if you've got a really long expression and a really long set of calculations that need to be performed over and over again, this can help out quite a bit. Okay. Next is the solve function, and this is one of the more powerful tools of the calculator, is that the calculator, using an iterative approach, basically making better and better guesses, can get you a really accurate answer for just about any equation that you want to solve. So the way that this works is I can plug in a given expression, let's say y equals ax squared plus b, and using solve, I can choose one of these variables that I'd like to solve for. Let's say I want to solve for x. I plug in all of the other values, and then the calculator will actually figure out what x needs to be to make the expression valid. So the first thing that we need to do is we actually need to enter this expression in the calculator. Now, you can follow this button for button input here if you've got any questions, but I want to walk you through what's going on. So we're going to use the alpha button quite a bit to start calling some of these alphabetical terms, A and B and X and what have you. So we'll start off, you notice we've got A, B, C, D, E, and F. We also have X and Y right here. So I'm going to go to alpha, Y. Now, instead of hitting the equals button, because we've got y equals ax squared plus b, we won't hit the equals term down here. We actually have to go to alpha and then calc, because if you notice there's an equal sign right here. There's a difference between entering a symbolic equal sign that we would use for a solve function versus having the calculator just do some math, and that's what this button down here is for. So make sure when you're doing this, you're using the alpha equals button right here to call the equals character. So we have y equals ax squared plus b, so alpha a, alpha x, and then we need to square that. We can do that one of two ways. We could use an exponent, or we could just use the squared button right here, and it automatically does that. And then plus alpha b. And when it's all said and done, you should have a display that looks something about like this: y equals ax squared plus b. Okay. Now what we need to do is we need to solve this expression. So we go to Shift, Solve, and you can see right there above the calc we see the Solve button. Now the way that this works, we have to provide some of the constants that go into this expression to solve for the remaining variable x. So let's say we have y equals ax squared plus b, and we know that y equals 0, we know that a equals 1, and we know that b equals 2, and we want to solve for x. So we go to our expression, we say y equals 0, a equals 1. Now notice it's listing a equals 7 because that's actually the last value that we used when we were using the calc function. So we overwrite that by saying a equals 1. And b, see, it's 20 because that's what we used last time. We need to use input -2. Now to input a negative number, we don't use the minus sign. We use this negative sign right here above recall, so -2. The minus sign is actually an operation, taking two numbers and combining them together. If you put -2, the calculator really wouldn't understand what's going on because it's looking for a single number. So make sure you're using the minus sign when you're dealing with negative values. So we've got y equals 0, a equals 1, b equals -2. We hit enter and then solve for x. Now the way that the solve function works is we have to provide an initial guess, some starting point for the calculator to begin to whittle down to the final answer. So depending upon the complexity of your calculation, sometimes this really matters. So later on we'll use tools like table and whatnot to plot expressions, and that'll help guide us towards making appropriate initial guesses. But for now, we'll just make an initial guess just right off the bat. Let's just say x is close to 1. So we'll try x equals 1, then we'll hit equals. And if you've done this correctly, you should have a display that looks something about like this. You should have the equation on the first line. The second line should give you a value. So we have x equals 1.414, and then the bottom line should say L minus R equals, and then the value should be pretty close to 0, if not exactly 0. So let me explain what that display means. Okay, so here's the display that we just looked at, and it's blown up a little bit, and hopefully this kind of illustrates what's going on. So first off, the first line is the original equation. So it gives you sort of a summary of, what did I originally enter. So if your answer doesn't make sense, that's probably one of the first places you'll want to look is, did the original equation look right? Now the middle line gives you the variable that we're solving for. In this case, we're solving for x, and x equals 1.4142 whatever. So this equation did not yield a very pretty or a whole number, I guess I should say. It wasn't x equals 7. It was a very trailing decimal type answer. The bottom line is a measure of the accuracy of your solution. Basically, the way the calculator is operating is when we provided our initial guess, in this case we provided an initial guess of x equals 1, what happened is the calculator took the value of 1 and it plugged it into the expression, and it compared what was the left side of the equation and the right side of the equation. So here's the left side, and then here's the right side. And then dependent upon that comparison, the calculator then decided, well, does x need to be a little bit larger, or does x need to be a little bit smaller? Since our initial value was 1 and the answer is 1.4, the calculator decided, oh, well, we need to increase 1 a little bit. And so it does this operation over and over and over again, increasing it a lot, then increasing it a little, and slowly but surely, well, it's actually really fast because it's doing this within fractions of a second, but it's incrementally getting towards the final answer. So after doing a bunch of iterations, we arrive at an answer of 1.414, etc. The way the calculator determines whether or not that answer is correct is it takes the left side of the equation, so it would, in this case, evaluate y, and then it would evaluate the right side of the equation, ax squared plus b, and then take the difference. If the left side of the equation truly does equal the right side of the equation, then L minus R should be 0. Okay? So the closer L minus R is to 0, the better the accuracy of your answer. So in this case, our answer is really accurate, or if not exactly accurate, because L minus R is in fact 0. This is a pretty basic equation, but sometimes if you've got a really complex equation with exponents and logarithms and trig and things like that, it may not be exactly 0. It may be 0.0001, etc. But in those cases, those numerical approximate answers probably are good enough for what you're doing. I have here another example that I wanted to walk through with you real quick. This is an equation that's a little bit longer, but again should hopefully give you kind of an idea of what's going on. So this expression, I'm actually going to move the calculator over here, so that we can see the expression. What we're going to do is we're going to evaluate a similar equation, only the equation is much longer. This is one of those equations where it's very difficult to solve for a value of x in what we call closed form fashion. For instance, if you've got an equation, let's say, like this, you could probably solve for x by hand. That's an equation that's very easy to solve by hand. This is not an equation that's very easy to solve by hand. So in practice, you really would use an iterative or numerical approach to solve this. So this is where the calculator really starts to shine. So first off, let's clear the out of the solve mode that we were using before by pressing the AC button, and then I'm gonna clear my keylog, and I might stretch this out a little bit so we can see what I'm entering. Okay. So I'm going to enter in this expression, and I'm going to take my time with it, but in the end I think you'll see it's pretty straightforward. So we do like we did last time. We go to alpha y, and then again alpha equals alpha a, alpha x, and then now because we have an x to the 4th, we don't have x squared like we did last time. We actually have to use the exponent key. So right here under the D-pad, you have this x raised, and then there's a square right here. That's the button that we would use. It actually brings up the exponent key, so we do x to the 4th. And then to get out of this exponent entry mode, we have to enter the press right on the D-pad, and that'll get us out of the superscript, and then we can move on. So plus, and then I think you'll see this is pretty rote from here. So alpha b, alpha x raised to the 3rd, get out of the superscript, plus, and then we keep trucking. So we've got alpha c, alpha x, and we could use the exponents, or we could just hit the square button. Either one would work. I'm going to be lazy and just hit the square button. We don't have to press right to get out of the superscript in that option. So plus alpha d, alpha x, plus alpha e. And you can kind of see, the equation's a little bit longer to enter, but again, this is where the calculator comes to shine, because imagine doing this equation by hand. So now we've got the calculator, or the equation built in. Now it's time to solve. So shift solve, and then now it's starting to ask for values. So if you look here right next to the calculator, I've got the values that we're going to use. So we're going to say y equals 10, a equals 1, b equals minus 2. If you notice for a and b, we actually probably didn't have to enter those values in at all. No, probably we really didn't, because from the previous time we used the calculator, we had a equals 1 and b equals minus 2. So if we wanted to be lazy, we could have just pressed enter and used those values over again. But because I want to be diligent, I just want to sort of go through the process and ensure that the values are what I want them to be. So continuing on, c equals 4, d equals 5, and e equals 1. Again, we must provide an initial value of x. Now, if you notice, if we didn't do anything, the initial value for x would actually be what we used before, which is what was solved for before, the 1.414. The way the calculator operates is unless you specify otherwise, the calculator automatically stores the constants that were previously there. So we previously solved for x and got 1.414, etc. So that's the value that the calculator lists. I want to use a value of 1, so x equals 1. So press enter. And if you've done this right, you should have a result that looks something like this, and your display should match what's on the slide. You should have an x of 1.087966059, going on, and your left side minus your right side should equal 0. So that indicates that you have a value of x that meets the requirements of the equation and is, in fact, fairly accurate. So hopefully that gives you a little bit more practice in solving that equation. So let me clear this real quick, and then I'm going to clear my keylog. And then we're going to move on to the final topic of our lecture today, which is equation or modes of the calculator, particularly the equation solver mode. Now, when you are solving, just a random equation that could have sines and cosines and exponents and square roots, things like that, the solve function works very well because you can literally plug in any equation that you want, and the calculator will find you a solution. But if you're solving what I would call a typical equation, in other words, an equation that is already pre-built into the calculator, then the equation mode, I would say, is much faster. Equation mode can be used to solve 4 different types of equations, and we're going to go through all of them. 2x2 systems, 3x3 systems, and then quadratic equations and cubic equations. We're going to go through each of these one at a time. But the long and short of it is, if the calculator already has these pre-built into them, you're definitely going to want to use these equations as opposed to others. So the equation mode can be used for a variety of equations. Let's go through each of these one at a time. Now the way that you go into equation mode is to hit the mode button. So right next to the D-pad, we have setup, which is what we explored last time. If we go to shift and then setup, you'll see this is where we can convert from degrees and radians and scientific notation and things like that. I'm going to hit AC to get out of that. But if you just hit the mode button, you'll notice it brings up a different menu that should look something like you see down here. So there's a number of different modes that the calculator operates in. You can do statistics with number 3, matrix operations, table functions, vectors, things like that. And we're going to explore some of these in class as well. You can even press the down arrow and there's more things going on like inequalities, distributions, and what have you. I'm more interested in mode 5, the equation mode. So if you press mode 5, there's 4 options that you can use. Now we're going to explore the first 2 in this video and then the next 2 in the following lecture after the technical conference. So let's discuss modes 1 and 2. So modes 1 and 2 are revolved around solving simultaneous systems of equations. And you've probably seen problems like this before, whether it was in high school or whether it was in some of the math courses that you've taken in college, maybe Math 127 or Math 132. But the idea is that if you have 2 equations and 2 unknowns, something like x plus 2y equals 3 and then 2x plus 3y equals 4, there's usually, and this opens sort of a can of worms in the world of linear algebra and things like that, but usually what you would like to have happen is that there's a unique value of x and y that actually meets the conditions of both equations. Now what you'll see after we go through this example is that if you have an x value of -1 and a y value of -2, and you take those values and you plug them into these expressions. So for instance, if I look at the top one, -1 plus 2 times 2 is in fact 3. But that also meets the requirements of the equation down below. Because if I take 2 times -1 plus 3 times 2, I get an answer of 4. And x equals -1 and y equals 2 is the only solution, the only set of numbers that satisfy the requirements of both equations. And that problem is a very fundamental challenge that presents itself in a wide variety of aspects in engineering. So being able to solve this type of system is quite important in the world of engineering. Now, what I want to do is go through and discuss how the calculator goes about this. So if you notice, we've got 4 modes. We're going to select mode 1 because mode 1 is really referring to the 2x2 equations. So, you know, for instance, a n x plus b n y equals c n. It's basically saying, you know, equation 1 and equation 2. So when you hit option 1, what will happen is you'll have a table pops up that looks something like this. Now, right now this equation is full of, or this table is full of zeros. We have to go through and populate this equation with the appropriate constants in the equations. And it's pretty straightforward. So if I go to the first equation, I have x plus 2y equals 3. So these constants are nothing more than the coefficients that go before these values. So for instance, the coefficient before y is 2. This constant is 3. Since there's nothing here on x, that value is 1, because basically if you have no value there, it's like saying 1 times x, because 1 times x equals x. So all we'll do is, for this first equation, enter 1, 2, 3. So we just type in a 1, press enter, type 2, press enter, and type 3, and press enter. And you'll notice that the values in the tables are being updated with the appropriate values. Notice if I mess one up, I could use the arrow keys and go back here and say, oh, nope, that's supposed to be 3. But I want to go back and make that 2. Then go down over here, and we've got 2, 3, and 4. So 2, 3, 4. Once the table is completely populated with values, all we have to do is hit equals, and there we go. So x equals minus 1, press equals again, y equals 2. And that's all there is to it. So if I press equals again, the calculator goes back into that mode. So let me clear my key log real quick. I have here another example that I want to go through real quick. A couple things I'll point out. So I can go through and start entering values again. So we have 3x minus y equals 12. So 3 for the x. For the y, we need minus 1. So we have minus 1. We have to use that minus symbol as well. And then 12. And then negative x plus 4y equals negative 6. And negative 1 equals 4 equals negative 6 equals. And then once we've got that taken care of, press the equal sign again, and we start getting values. Now these values don't come out as whole numbers like the last example that we did. So remember, if you want an actual decimal value, that's where that S to D key comes into play, and you can swap back and forth. Press equals and swap back and forth. Okay. So that's a 2x2 expression. Pretty straightforward application. The calculator will also solve a 3x3 set of equations. And I can go to that by hitting mode, equation, and then instead of going to option 1, just going to option 2. Now, 3x3 systems are 3 equations and 3 unknowns. It's very similar. The problems are just a little bit larger, so they just take a little bit more time to enter. But in the end, the actual general process is the same. So I have here a similar table, and if you notice, I'll use the arrow keys to go around. You can see instead of having A, B, and C, I have A, B, C, and D because I've got more terms. So we're going to look at the following 3x3 system. So we've got 5x minus 3y minus 2z equals 1.2, and then you can see the other expressions. Really, we just have to have a little bit of patience to go through and enter the values in as we see them. So I've actually written a table down here that we can follow when we're going through entering these values. So 5, then we got minus 3. And we can just sort of go through this. So minus 2, then 1.2, and your decimal symbol right there. minus 3, 7, minus 4, 0.6, minus 2, minus 4, 7, 0. All right. When it's all said and done, you should get, again, a unique set of x, y, and z values that meets the conditions of all three equations. In other words, I have an x value, which is 57 over 26, or about 2.192, something like that. A y value, that's 267 over 130, or 2.0538, something like that. And then z is 9/5, or 1.8. In other words, if I took each one of these values and plug them into this equation, and this equation, I promise you that 5x minus 3y minus 2z does in fact equal 1.2, and minus 3x plus 7y minus 4z does in fact equal 0.6, and etc. So it's a pretty powerful tool that the calculator utilizes. One final note I'll point out, if I start hitting equals or I start hitting AC, it's almost like the calculator is stuck in this equation mode. And if you're thinking, wait, I want to go back to just using the calculator normally. I just want to go back to doing basic computations. The key is to go to mode and then hit 1. Okay? It's something we really didn't talk about at the beginning, but actually this entire time we've been utilizing the calculator under mode 1. If we go back to mode 1 says COMP. That COMP stands for computations. Essentially, this entire time that we were using the calculator, at least last time, we were operating under mode 1. So when we go to mode 5, we're actually under, let's say mode 5.3, we're actually under a different mode of operation for the calculator. But if we want to go back to square one, we just hit mode and 1. And then that will bring us back to normal operating conditions. So if you're ever in doubt during operation of the calculator, that'll get you back to square one. Okay, so that's all we have for this lecture. Next time what we're going to do is we're going to go back to the equation mode, what we've been doing here. This time we covered 1 and 2. Next time what we're going to do is cover 3 and 4 so that you know how to solve these. Engineering students will be solving quadratic equations and things like this all day long, so it's definitely something you're going to want to master. And then we're also going to explore the table function in the calculator, because the table function will operate a lot like a spreadsheet, but it will also assist you quite a bit during graphing or during plotting. So if you've got some equation and you want to know what it looks like and you don't have Excel or something like that available to you, you can use the table function to quickly generate an X and Y series of points for that given function and plot them, and that works out very quickly and very well. So we'll see you next time. Just again, make sure you're trucking along with the homework, and again, if you have any questions, you can feel free to contact me by email. All right, that's all we have.